Hello and welcome to a rough demonstration of my computer science NEA project, the Cluck compiler. Cluck is an implementation of the C programming language that I've been working on for the past few weeks, made with Haskell and LLVM. In this video, I'm going to show you a few examples of the compiler in action and show you the different options that the compiler provides for the developer's experience. So to start out with, I have a binary right here of the compiler. You can download this for yourself via the repository in the description. There is a pre-built binary for Linux x86, which should work on most major distros. So to start out here, I'm going to compile the first program, which I will show to you here. It's an implementation of the sieve of Eratosthenes algorithm, which simply prints out all the prime numbers up to a given number n. So after running the command, it has produced a primes binary right here, which if we run, the program prompts us to enter n, and I'll enter 100, and there we go. So this program right here demonstrates a few of the compiler's capabilities. So in terms of parsing, it can handle regular and block comments. It can handle nested expressions, operator precedence, binary operators. It can also handle typecasts right here, pointers, memory indexing, for loops. And it also has some built-in C functions built in, such as printf, free, and malloc. So the second program we have here, trig.c, this is simply an approximation of the sine, cos, and tan functions using the Maclaurin series. And so what this is going to do, if I compile it right here, it's going to prompt us to enter the value of x in radians. So if I enter 0, it's going to give us an approximation of sine, cos, and tan. So as you can see here, 0, 1, and 0, that sounds about right. If I run it again and enter a value close to pi, it's going to give approximately 0, approximately 1, and approximately 0. So this program right here, again, just showcases using if statements, different types of selection. It also showcases that recursion is possible with this compiler via this factorial function. Also format strings with scanf. The compiler comes with a few command line options to help with debugging the compiler and for the development experience. To start out with, the -a flag outputs the abstract syntax tree of the source file. For example, if I enter the source file here and pass -a, it will print out the entire AST for the source file in Haskell syntax. This is mostly for debugging purposes, but it can also help understand how certain operator precedence rules work, for example. Another flag you can pass for a source file is the -s flag, which will actually just generate an LLVM IR file corresponding to that source program. So these are the actual LLVM IR instructions that are underlying the C program. This is what is being passed to Clang before it gets converted into an executable. And this was also quite a helpful tool for debugging the compiler. The final flag that I will show you is the -h flag. And this will simply just generate a header file for the source file that is provided. So if I output this, it's just going to have a single declaration int main. I'm now going to demonstrate the developer experience while using this compiler when it comes to error checking and syntax errors. So to start out with, I'm going to create a new file, let's say test.c, and I'm going to input a program which is obviously syntactically incorrect. So let's return 0, let's not put a semicolon there. Let's compile that. As you can see, I've got a syntax error here, unexpected closing brace, and it was expecting any one of these things, notably a semicolon. And what's great about this syntax error is it contains the exact line that the parser failed, and also the column, and also the source file which this happened in. This works for all kinds of syntax errors. So let's try another one. Let's try doing a for loop where we only put one expression in the middle. So let's say I is less than 10. Obviously that's not enough to create a for loop. Let's do that. And as you can see, another syntax error right here, unexpected closing parentheses. And these errors extend beyond syntax. I've also implemented semantic errors into the compiler. So for example, let's have a variable I, and let's try and assign it a value that it cannot hold. So for example, a float. If I try to compile this, error cannot assign to mismatch types, expected int but got float. So this is really useful to developer as it prevents undefined behavior. Using a conventional C compiler, this value 3.5 would actually get truncated to 3, which could result in unexpected behavior. Another semantic check that I've implemented is that functions actually return each time. If I implement a function called test, which has a return type of int, of course, if I have a condition, if I give it a parameter, let's say a, and I say if a is greater than 10, then we're going to return a, and then do nothing else. Let's call a right here. Let's call it with 11 or 9. So in this instance, when test is called here with the value of 9, this if statement is not going to run, and the function will not return, which should result in undefined behavior, which is obviously something we want to stop. So if I try and compile this, I'm going to get an error. Non-void function test does not return a value in all control paths. And the reason why this happens is because the compiler performs a control flow analysis of each function to ensure that it returns a value in all control paths. Another semantic check that I want to show is obviously checking that a function is always called correctly. So here I've called the test function without passing a parameter. And oh, I still got the same error from last time. And here we are, expected 1 argument in call to test but got 0. So the compiler is going to vigorously check that function calls, variables are all initialized at the correct values in the way that they were defined to prevent undefined behavior, which is the enemy in C programming. That is the end of the video. Thank you so much for watching this demonstration. I hope it was interesting and useful if you want to undergo one of these projects yourself. As previously mentioned, all the source code and the pre-compiled binaries are available in the link in the description if you want to have a look, as well as all of the articles and resources that I used while developing this project, and that will all be linked in the description. Thank you for watching.